Running is an activity associated with having fun. It certainly doesn't have anything to do with mathematics. However, our team, after watching a number of track events, was able to analyze a very normal mathematical pattern in the way stamina works in relation to distance. Hey there! Running is an inevitable aspect of life. We've all had to run at some point in our lives, be it for the purpose of catching a train, a flight, a taxi, or even an 8 o'clock class. Perhaps the most widely covered form of running is track sprinting. Track sprinting involves not only having an abundance of stamina, but also the right combination of body movement, speed alteration, and acceleration.
While watching track events, our team, which comprised of Ayan, Mirel, Jelly, and I, noticed a pattern in the distance and speed of athletes. Therefore, we decided to conduct an experiment which would allow us to analyze these patterns very closely. After this experiment was conducted, we decided to graph our findings to represent the phenomenon in a mathematical way.
Mathematically, the finding could be interpreted in the form of a modular sign graph. The x-axis represents the cumulative distance and the y-axis represents the speed. We included the modulus so that the graph bounce off the x-axis. This is done to maintain the logicality of experiment. For speed cannot be negative and the graph must begin at 0 because there's no acceleration.
We noticed several patterns while conducting the experiment. First, both runners accelerated and gained top speed by the 100-meter mark. It took Ayan 12.5 seconds to cross the 100-meter mark, while it took Muis 13.6 seconds. After the 100-meter mark, however, both runners witnessed sharp declines in speed and gradually slowed down to complete the next 100 meters, with 15.5 seconds and 16 seconds respectively.
We set up the experiment in a football field near the old Canadian Pre-University campus. In order to measure speed and distance accurately, we set up 4 50-meter intervals. The course was essentially just a normal 200-meter sprint, but we had runners who do not possess an abundance of stamina.
Also, to keep it fair, we used runners who have similar physics and stamina.
Every single one's got a story to tell. Everyone knows about it. From the Queen of England to the hounds of hell. And if I catch it coming back my way, I'm gonna serve it to you. And that ain't what you want to hear, but that's what I'll do. And the feeling coming from my bones says find a home. I'm going to Wichita. Don't wanna hear
A similar pattern may be observed if the same experiment is conducted with 2 other runners with similar physiques but different sprinting abilities. The pattern for 2 professional sprinters, for instance, would be similar but much steeper than the one we obtained from this experiment, largely because of the huge difference in speed. Take these scenarios for example. Number 1. Professional sprinters run the same distance and time is taken for each interval. Given their ability and stamina, there's a strong likelihood that the average speed that they have for each interval will be much higher than that of the runners we used in our experiment.
Over a 100-meter interval for the same runners, there is a strong likelihood that the graph will be linear, largely because of the fact that in the current scenario, there is a decline in speed after the 100-meter interval. In this case, the function of the graph will be a linear for the first 100 meters, which can be seen from the figure below. Our results and subsequent research suggest that in a 100-meter sprint, runners are the fastest when they approach and cross the finish line. However, this isn't the case in a 200-meter sprint.
We conducted another experiment, a secondary one, in order to find out if the pattern of our graph would be the same or not. Here's what happened. Two people who are not very accustomed to running attempt to run across the same intervals. Their physical condition and stamina will result in the following pattern. Although it took the runners a lot more time to cross the intervals, the basic pattern of the graph remained the same.